Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this Olympiad math equation. So we have a to the power of 3 plus a squared is equal to 80. And we want to find the value of a. So our solution. So we start with, obviously, a to the power of 3 plus a squared is equal to 80. And now what I'm going to do is I want to get all these terms on one side. So I'm going to move 80 to the left-hand side by subtracting 80 on both sides. So now I have a to the power of 3 plus a squared minus 80 is equal to 0. Now 80, this is the same thing as, negative 80, this is the same thing as negative 64 minus 16. So I'm going to rewrite this as a to the power of 3 plus a squared minus 64 minus 16 is equal to 0. Now I'm going to individually factor these out. So a to the power of 3 negative 64, I'm going to move these together. So now I have a to the power of 3 minus 64 plus a squared minus 16 is equal to 0. Now, 64, this is the same thing as 4 to the power of 3. And I'm changing it to 4 to the power of 3 because, as you can see, we have a to the power of 3, so it's better to change this into something cubed. So now I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 16 is equal to 0. Now, a squared, I want to change 16, so it's something to the power of 2. Well, 16, this is equal to 4 to the power of 2. So now I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 4 squared is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus 2ab plus b squared. So in this case, a is a and b is 4. So a to the power of 3 minus 4 to the power of 3, this is going to equal a minus b, so a minus 4 times a squared plus 2a times 4 plus b squared, so 4 squared. Now we can go ahead and simplify this a little bit. This would equal a minus 4 times a squared plus 2 times 4, that is equal to 8. Oops, sorry, it looks like I made a mistake. This is not 2ab, this is simply just ab. So, just going to be 4a plus 4 squared, this is 16. So now, I have a minus 4 times a squared plus 4a plus 16 plus a squared minus 4 squared, and this is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a minus b times a plus b. So in this case, a is equal to a and b is equal to 4. So a squared minus 4 squared, this would equal a minus 4 times a plus 4. So now I have a minus 4 times a squared plus 4a plus 16 plus a minus 4 times a plus 4 is equal to 0. Now, as you see, both the terms have a minus 4. So I'm going to factor out a minus 4. And if I do that, I get a minus 4 times a squared plus 4a plus 16 plus a plus 4 is equal to 0. Now over here, I can go ahead and combine like terms. 4 and a are like terms, and 16 and 4 are like terms. So now I have a minus 4 times 4a plus a is 5a, so I have a squared plus 5a plus 16 plus 4 is 20. And this is equal to 0. Now I have two equations. I have a minus 4 is equal to 0, and I also have a squared plus 5a plus 20 is equal to 0. For a minus 4 equals 0, all I have to do is I can simply add 4 on both sides. So then these two cancel out, and I will be left with a is equal to 4. Now for a squared plus 5a plus 20 equals 0, I'm going to be using the quadratic formula negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is equal to 1, b is equal to 5, and c is equal to 20. So now this would give me negative 5 plus or minus the square root of, just normal 5 squared minus 4 times 1 times 20 all over 2a, so 2 times 1. Now this is equal to negative 5 plus or minus the square root of 25 minus 80 all over 2 times 1 is 2. Now this is equal to negative 5 plus or minus the square root of negative 55 over 2. Now, the square root of negative 55, this can be written as the square root of 55 times I. And I, this is equal to the square root of negative 1. So I have this over 2, and this is two more solutions to this problem. Alright, so in this problem, I have x minus 2 to the power of 3 is equal to negative 8. So to solve this, I'm going to first start by adding 8 on both sides. So then these two cancel out, and I get x minus 2 to the power of 3 plus 8 is equal to 0. Now from here, I can rewrite 8 as 2 to the power of 3. So I have x minus 2 to the power of 3 plus 2 to the power of 3 is 0. And the reason I did that was because if I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. So in this case, a is equal to x minus 2 and b is equal to 2. So I get x minus 2 plus 2 times x minus 2 squared minus 2 times x minus 2 plus 2 squared. And this is equal to 0. Now we can simplify this. So negative 2 and positive 2 cancel out. So I get x times x minus 2 squared is the same thing as x squared minus 4x plus 4. And then negative 2 times x minus 2, I can distribute the negative 2. Negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. And finally I have this plus 2 squared, which is equal to 4. Now from here, we can simplify what's in the parentheses. So I get x times x squared minus 4x plus 4 minus 2x plus 4 plus 4. So this simplifies to x squared. Negative 4x minus 2x is negative 6x. And now I'm left with plus 4 plus 4 plus 4, which is plus 12. This is equal to 0. Now from here, this gives me two equations. I get x is equal to 0, and I get x squared minus 6x plus 12 is equal to 0. So x equals 0, this is already a solution. And x squared minus 6x plus 12 is equal to 0. To solve this, we're going to have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 6, and c is 12. So if I plug these values in to my quadratic formula, I get negative 6 plus or minus the square root of b squared, so 6 squared, which is 36, minus 4 times a, which is 1, times c, which is 12, all over 2a, so 2 times 1. And this is equal to negative 6 plus or minus the square root of 36 minus 48 over 2 times 1, which is 2. And this is equal to negative 6 plus or minus the square root of 36 minus 48, which is negative 12 over 2. Now from here, a negative 6 plus or minus the square root of 12 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is the same thing as the imaginary number I. So I get x is equal to negative 6 plus or minus the square root of 12i over 2. Now the square root of 12, this is the same thing as the square root of 4 times 3, right? Which is equal to the square root of 4 times the square root of 3. The square root of 4 is 2. This is equal to 2 root 3. So I get x is equal to negative 6 plus or minus 2 root 3 I over 2. Now if I divide my terms here by 2, I get x is equal to negative 3 plus or minus, these two cancel out, square root of 3i. So my three solutions are x is equal to negative 3 plus the square root of 3i, x is equal to negative 3 minus the square root of 3i, and x is equal to 0.